So I gave you the formula sheets, and we're talking about the sum or difference formulas today for 5.4. And when you look at them, there's a sign where you're adding two angles together, a sign where you're subtracting two angles. So that's why they call them sums and differences. So there's a sine, a cosine, and a tangent formula. When you look at them, the pattern stays the same. And then when you do tangents, it would be like when you do the sum, you do the tangent, sum on top, and then the sign would switch underneath. So just watch the pattern, you got your formula sheets. So the idea is when you do a cosine of 75, there's no 75 on the unit circle.
You gotta add.
You're gonna have to add or subtract things together. So in this case, what are some ways that we could get 75 degrees?
Probably 30 and 45.
30 and 45.
30 plus 45, what else?
15, 60. You need a 5 in this.
Yes, but there's no 15 on the unit circle.
Oh, yeah.
120 minus 45, right? So if you do these problems in a group, somebody might grab a set of numbers of like 120 minus 45, you're doing 30 plus 45. Finish it. Both of you do it the different ways and make sure you're getting the same answer. So let's just do the 30 plus 45. So what I'm going to do is write down the cosine of 75. Can also be written as the cosine of 30 plus 45. So I'm not changing the value, I'm just changing the way this looks. And then when you look at the cosine formula, it goes cosine, cosine, sine, sine, and the positive or negative will not match. So you're just going to go cosine of the first angle times cosine of the second. Because you're adding the two angles, when you look at the cosine formula, it's this one right here. So then you subtract, and now you do sine of the first angle, sine of the second angle. So basically you've named 30 the U and 45 the V. But now these are numbers that you can quickly find on the unit circle. What is the cosine of 30? Root 3 over 2. What's the cosine of 45? What's the sine of 30? What's the sine of 45? So I go ahead and I write all these down. And then now when you multiply fractions, you multiply top, multiply bottom. So what's root 3 times root 2? Root 6 over 4. 1 times root 2 would just be root 2 over 4. And so my final answer would look like root 6 minus root 2 all over 4. So what they'll always say is find the exact value. So what we're going to do is double check that we have this right. So I go to my calculator, make sure you're in degree mode. So what is the cosine of 75? 0.2588. So now I'm going to type in, I had the square root of 6 minus the square root of 2 divided by 4. Should be the same decimal, and it is. So it definitely worked.
The next one.
So now with the sine of 15, what are some combinations that will get you to 15? 60 minus 45. 45 minus 30. And then you could jump into the quadrants and do 150 minus 135. But since these are in the first quadrant, these are really easy to work with. Let's go ahead and do the 60 minus 45. So when you do a sine of 15 degrees, we're going to switch it to the sine of 60 minus 45. So this will allow me now to do the sine formula up above. And the sine formulas go sine, cosine, multiplied, cosine, sine, and the adding or subtracting matches this time. So I'll go sine of 60 cosine of 45. Because I'm subtracting in my formula, I'll be subtracting here for the signs, they match. And then you switch the order and you go cosine of 60, sine of 45. So all you have to do is follow the pattern that's right on the formula sheet. So the sine of 60,
1/2.
sine of 60,
Root 3 over 2.
root 3 over 2, cosine of 45 again is root 2 over 2. Now the cosine of 60 is 1/2, and the sine of 45 is root 2 over 2. So now when you multiply these out, you end up with that root 6 over 4 minus root 2 over 4, which is a root 6 minus root 2 over 4. So in this last problem, while we're getting set up, can you convert 7 pi over 12 to degrees for me quick?
So you just times it by like 180 over 5?
Yep. Your life will be a lot easier in degree mode, so go ahead and do the conversion. What do we get? $105, I think.
Yeah.
Okay. So we're talking about 105 degrees. What are some combinations that will get me to 105 degrees?
135
135 minus 30.
90 plus 15. Oh, wait, no.
60 plus 45. And there are other combinations. I tend to use the ones that are in the first quadrant if I can, because the first quadrant is typically things that you've memorized. So let's use those again. So now we're doing the cosine of, instead of 7 pi over 12, it's 105, which can also be written cosine of 45 plus 60. Because you're adding these two things together, it doesn't matter which one you put first. But when you do the cosine formula, if you look at it, it goes cosine, cosine, sine, sine, and then if you're adding your angles together, you'll be subtracting in the formula. So just follow that pattern. So cosine 45, cosine 60, then minus sine 45, sine of 60. So it's almost identical to the ones we've done before, just because we're trying to stick with the same angles. So cosine of 45, root 2 over 2, cosine of 60, 1/2. Sine of 45, root 2 over 2, sine of 60, root 3 over 2. So again, we end up with root 2 minus root 6 over 4.
Is that always going to be that?
No, it will not always be that. It just happened, it's because we're using the same angles all the time. The tangent graphs, or the tangent equations tend to be a little bit more difficult. It's just harder to work with tangent because it's not stuff right on the unit circle. But what are some combinations for 195?
135 and 60.
135 plus 60.
So we're adding 225.
150 plus 45.
225.
225 minus 30, right? So there are a lot of different combinations that we can use. Let's just do
See the top one?
the top one, that's fine.
Sounds great.
Alright, so the tangent of 195 can be written as the tangent of 135 plus 60. You know what? To show you a little trick, I'm actually going to switch this out.
Good thing I wrote it with pen.
Yeah. I don't want to do that one. Just thinking ahead, I want to do the 150 plus 45.
Awesome.
So I want to show you a little trick in the middle of the problem. Sorry. All right. So when you go to do tangent, the tangent formula is a little more difficult. So you start with tangent of 150 plus tangent of 45. So if you're adding your angles together, if you look at the formula, if you add your angles together, then you add a tangent of each angle on top, right?
Yeah.
But on the bottom, you go 1 minus the product. So 1 minus the product of these two angles. So that will be the formula that you have. Multiplication, yes. Adopt. So, what is the tangent of 150? And again, hopefully you have started memorizing the tangents. We're talking about 150, which is going to behave like a 30-degree angle. So what's the
It's on. Are you asking someone?
No,
No, you're talking. Sorry.
but you're in the second quadrant, so it's negative root 3 over 3, but that's good. What's the tangent of 45?
For 2 and for 2.
1.
Or 1, yeah.
Plus 1. Then you go 1 minus negative root 3 over 3 times 1. So you fill in all your tangents. It's a little more difficult to work with tangent, but also the formula can be a little more difficult. So I'm just going to do one step to clean it up. It's negative root 3 over 3 plus 1. 1, and then this is a negative answer, so when you say 1 minus a negative, you end up with 1 plus root 3 over 3. So this is why I switched to the 150 instead of using the 60. Because we have these extra fractions in here, we have a square root on the bottom, it looks kind of messy. So one thing that we can do is multiply by 3 over 3. What's 3 over 3? 1. So I'm not really changing it, but now when I distribute to the top and distribute to the bottom, it'll help get rid of those fractions. So now you have negative root 3 plus 1 over 1 plus root 3. So when we go to multiply by the conjugate, if you will, to get rid of the, or to rationalize this thing, it'll make our life easier. So I'm going to bring that answer over here, and I have negative root 3 plus 1, 1 plus root 3. What do I multiply by to get rid of the square root? 1 minus root 3, 1 minus root 3. So what I'm going to do is let you have a moment here to try to multiply that out and see what you get. When I did this step right here. So 3 times that would get rid of the fraction, but these should have been 3's. Sorry. Thank you. Right? 3 times 1 is 3.
That's right.
Where were you on that one?
Sorry.
So these should have been 3's. Sorry. These should have been 3's. My mistake. So now when you go to multiply by this conjugate, this has to be a 3 also. Apologize about that. 3 times 1 is 3.
It's okay.
See, even I make
Just ruined
mistakes.
everything.
But now you're going to take a moment to try to multiply this all out and simplify it, and then I'll come back and show you the answer. So, across the top, I would start with this negative 3. Take this negative 3 and distribute to both of them. So negative 3 times the 3 would be negative 3 root 3. Negative root 3 times negative root 3 is positive 3. 3 times 3 is 9. And 3 times negative root 3 is a negative 3 root 3. On the bottom, because these are similar to conjugates or difference of squares factoring, I only need to do the first and the last. The OI adds up to 0. So just do 3 times 3, and 3 times 3 is 9. Root 3 times negative root 3 is negative 3. So that's multiplying it all out. So you have some like terms, you have a 12 here. Negative 3 root 3, added to that negative 3 root 3 would be negative 6 root 3, all over 6. So the final thing, it would be hard, break it apart. What's 12 over 6?
This is so much.
What's 12 over 6?
2.
Why couldn't it?
What's 6 over 6?
I got no time.
So let me show you something. So yeah, this tangents are a little bit more difficult. Obviously, there's more stuff going on, and to get your exact answer. So let's type these in. Tangent of 195 and 2 minus root 3. So the tangent of 195, and then we had 2 minus root 3. So right now we just verified that our answer is correct. Alright, so if I look, this is an equation. It says find all the solutions. So it's the sine of x plus pi over 4, and we're adding a sine of x minus pi over 4, and it's set equal to 1, negative 1. This is called the sum of sines. So the sum and difference, if you look at the top of our formula sheet, we're adding two angles together. One just happens to be an x, and the other one's a pi over 4. So how do you expand that out into its rule? Sines go what? Sine of x cosine pi over 4 plus cosine of x
Where'd you get the cosine?
sine of pi over 4. That's just following the pattern. When you add, look at the sine of u plus v. The sine of u plus v, so you go sine, cosine, cosine, sine. Now the second part of this, we're adding sine of x cosine of pi over 4 minus cosine of x sine of pi over 4. And this is equal to negative 1. Just following the two patterns. Sine of u plus v, what do you do? And sine of u minus v, what do you do? Now, when you look at this, there's a positive cosine of x sine of pi over 4, positive, and a negative. Those two things were identical. One's positive, one's negative, so you can get rid of them. Then you have a sine of x cosine of pi over 4, and you have another sine of x cosine of pi over 4.
Negative 1.
So you have 2 sine of x cosine of pi over 4 equals negative 1. This is just like yesterday. What is the cosine of pi over 4?
It's 40. Wait,
Oh, shit. Oh, divide by 0.
Watch. Right now I am multiplying by 2 up front. I'm also multiplying by a root 2 over 2 at the end of the left hand side here. So if you're multiplying by 2 at the same time you're dividing by 2, what can you do? Those two you could get rid of. And once you get rid of these,
Oh, yeah.
I get it.
so I got rid of the 2's, so I'm going to divide this side by root 2 and divide this side by root 2. So what we're really looking at solving is when is the sine of x going to be equal to negative 1 over root 2? You can't have the root 2 on the bottom. So if you quickly rationalize that, what they're really asking is, when is sine negative root 2 over 2?
Oh.
So 45-degree angles, but sine is negative in the bottom too. So what are your negative or your 45 down there? 225 and 315. So you're going to work on the DIY. So I'm going to pause the video, and then whoever's watching can pause it. They can do it. I'll put the answer up in a second.
They don't really DIY. Gotta be
So here's what it would look like. When you do the cosine, here, cosine, cosine, sine, sine. When you do the cosine here, cosine, cosine plus sine, sine.
Oh. What?
So cosine of pi over 2 is at the top of the unit circle, which you have not moved left or right, so your cosine is 0. So that's going to wipe out this term. And then you have this negative sine of x. And then over here, cosine of the 3 pi over 2 is also 0, so it's going to wipe out this term, right? And so you end up with a negative sine and a negative sine, and that will be your negative 2 sine of x. And so at the very end, you're asking the question, when is sine negative 1/2? And they say 7 pi over 6 and 11 pi over 6, which is the same as 210 degrees and 330 degrees.
Where'd you get the -2 from?
So the last question. It says let cosine of, I think it's an alpha, right? So let's just call this, we'll call it A, and this is a beta, let's just call it B. So I may refer to them as A's and B's. It's just easier for us. So they're saying let cosine of A be 4/5, sine of your beta or B be 5/13. Let A be between 3 pi over 2 and 2 pi. So, I'm going to take this information along with this piece right here. So I'll underline them in purple. We're going to draw x, y axis over here. 3 pi over 2 to 2 pi is talking about the fourth quadrant. So we're going to draw a triangle in the fourth quadrant. We'll put our little a or alpha in the corner. Adjacent over hypotenuse. So 4 is the adjacent, hypotenuse is the 5. What's the missing side? It's a 3, 3, 4, 5 triangle. But remember, in this diagram, the 3 is in a downward direction, so you have to make it negative.
Negative.
Then we'll take the sine of beta is that, along with that information. Where's pi over 2 to pi? Where's pi over 2 to pi? Up in the second quadrant. Call it beta or B. Sine is opposite over hypotenuse. So opposite 5, hypotenuse 13. What's the missing side here?
12.
But it's going left, so you have to make it negative. So use your Pythagorean theorem twice if you need to.
Yeah.
What they're trying to get us to find is this. What is the sine of alpha minus the beta, or A minus B? So I'm going to write the formula out. Sine cosine minus cosine sine. And then you have all your information right on your two triangles. What is the sine of A? Well, that's coming from the purple triangle, and the sine is opposite -3 over hypotenuse 5. Cosine of B. Go to your green triangle. What's the cosine of B? -12 over 13, adjacent over hypotenuse. Minus, again, you go back to cosine of A, which goes to the purple triangle. What's the cosine? It was also given to us, but it's 4/5. And then the sine of B, again, was given to us, or you can use the green triangle, and it's 5/13. So all we have to do is add these up. -3 times -12 is 36 over 65. 4 times 5 is 20 over 65. And so my final answer looks like 16 over 65.